Hi guys, welcome back to AP Environmental Science. In today's video, we're going to be covering topics 5.1 and 5.2. We're going to be talking about deforestation and the impacts of deforestation on the earth. So let's go ahead and get started. And you should be filling in pages 2 and 3. All right, and if you notice, I have started to do a little bit less and less of the fill in the blank notes, and these would rather instead be note frames. This is a good time for you to start practicing putting things into your own words and summarizing and abbreviating, because in college you're not going to get fill in the blank notes like this. All right, let's go ahead and get started. Let's talk about clear cutting. Okay, so clear cutting is going to be the removal of trees, just cutting all of them down, and these would be the effects or the impacts of clear cutting. So the first one is soil erosion. Because roots hold soil in place, clear cutting an area removes the stabilizing effect those roots have on the soil. This leads to loss of soil organic matter and nutrients found in the topsoil, which is easily blown by wind and washed away by the rain. That's erosion. So without the roots to hold the trees in place, your soil is going to be less stable. It's more likely to blow away, probably washed away. We can see this in this picture here, where the wind and rain are carving these channels into the side of the slope and washing away the topsoil, which has no roots in its place. This also results in sediments being deposited into nearby streams, which increases the turbidity of the water. And turbidity is a measure of the total suspended particles in a water source, typically like how cloudy it is. This makes it cloudier and harder for animals to get oxygen from the water and plants to get sunlight underwater. If water is more cloudy or highly turbid, your light isn't going to penetrate as far down through the water, impacting productivity of an ecosystem. We can see in this diagram, when trees are present along the banks of a stream, they catch a lot of the sediment being eroded from the hillside above, but without them in the clear cut diagram, the runoff carries sediments right into the stream. So here we see that there's a bunch of trees along this water line. They're going to prevent a lot of these sediments from being washed away into the stream. But when they're not there, the sediments are just going to be run off right into that stream. The second effect is increased soil and stream temperature. So the loss of shade provided by the trees allows more sunlight to reach the soil and the stream, which increases the temperature of both the soil and water. The effect of increased insolation is intensified by the fact that soil has a lower albedo than the leaves of trees, and darker, muddier stream water absorbs more sunlight than clear stream water. So we're bringing back in topics from Unit 2, which was our unit all about Earth systems. So remember, albedo is the reflection of sunlight. If you have a higher albedo, you're going to have a higher reflection of sunlight, okay? Meaning that you have a low absorption of heat. So high albedo will reflect more sunlight, thus you have more, higher albedo, more sunlight being reflected, less heat. Lower albedo, less sunlight being reflected, more heat because it's absorbing it. So the sediments themselves also bring heat into the water, raising its temperature, which can be harmful to species like fish that need high oxygen levels in the water, as increased temperature decreases the amount of dissolved oxygen in the water. And finally, we have the increase in occurrence of flooding and landslides or mudslides. Logging machinery compacts the soil, and increased sunlight dries it out. And these facts, combined with the loss of root structure and organic matter in the topsoil decreases the soil's ability to hold water. So when it rains, the soil holds less water and produces more runoff, which can flood nearby areas and cause landslides and mudslides, which destroy animal habitats and human structures, as we can see um, in the picture. So now let's move on to tree plantations. Another consequence of clear cutting is that it usually involves replacing the clear cut area with tree plantations, which are areas where they're usually only growing one specific species of tree, and it's planted all at the same time. And it's allowed to grow until they're large enough to be harvested. So the problem with this greatly decreases species biodiversity. It replaces mature, diverse forests with strands of trees that are all the same species. This makes the forest more prone to disease or natural disasters, lowering its resiliency. And it also makes it a less suitable habitat for many animal and plant species that may not be able to use this tree as a resource for food or shelter. So trees provide a great amount of biodiversity for ecosystems solely because they can be used as a food source and as a shelter source. So when you are clear cutting an area tree plantations, you are lowering the biodiversity because of this. This also results in stands of trees that are exactly the same age, which then can cause them to all directly compete with each other, and it doesn't provide any old dying trees, which are vital habitats and resources for so many species. So, for example, dead trees are utilized by woodpeckers, insects, and decomposers. And all of the trees here at the same age, you're eliminating not just the organisms that live in the types of trees that are there, but the different organisms that use them to live and survive and reproduce, such as these woodpeckers, insects, and decomposers. So let's talk about the benefits of a forest. So to understand some of the larger or long-term consequences of clear cutting, we need to look more closely at some of the most important benefits of forests. Remembering these are ecosystem services or valuable things that nature provides for us for free. So the first one is the free filtration of air pollutants. The stomata, or the leaf pores of trees and other plants, actually remove many pollutants like volatile organic compounds, nitrogen dioxide, and particulates from the air and either convert them into less harmful compounds or store them in the tree or in the soil. So this diagram illustrates how many of these pollutants that our cars, factories, and power plants produce that are pulled out of the air by the stomata of trees, especially large broadleaf trees like maples and ash. So forests are not just incredibly important for providing oxygen and a food source and shelter, they also filter air pollutants. And air pollution is a few units from now. So we'll learn more about volatile organic compounds, these VOCs. We'll learn more about these other particulate matters. That's what PM is in that unit. Also, then we have the removal and storage of carbon dioxide from the atmosphere, which is also known as carbon, oh my God, the word, a carbon sink, thank you. And this also can be another word used sequester, carbon sequestration, which is where you have carbon being removed and being stored. Plants and trees are photosynthetic. They also do cellular respiration, but they are photosynthetic, meaning that they breathe in or take in carbon dioxide. So trees are removing carbon dioxide from the atmosphere, which is good because we know from previous units that CO2 is a greenhouse gas. It causes a blanket over the atmosphere, preventing the sun's rays from being released back into space, thus warming the planet. So it's good that we have trees to be able to remove CO2 from our atmosphere. And finally, we know that forests provide habitat for a wide variety of organisms, which support biodiversity and provides beautiful places for ecotourism or people paying to visit and spend time in nature. Okay, so now what are some of these consequences of deforestation? Okay, so some long-term consequences of deforestation is the reduced ability of forests to filter air pollutants and CO2 from our atmosphere. Cutting them down, especially clear cutting them, also releases CO2 back into the atmosphere as the leftover tree scraps are decomposed. A method of agriculture called slash and burn, which is exactly what it sounds like, also releases the CO2 stored by trees. So what happens in slash and burn, the slashing is the cutting down the trees, and the burning is the burning of the trees. And this is used primarily for clearing land for agriculture. And when you burn them, you're releasing all of these greenhouse gases into the atmosphere. Now, this process does happen naturally with primary and secondary succession, which we're going to talk about in unit 4, but we'll bring it back a little bit in this unit. Primary and secondary succession is when habitats are destroyed and kind of regrow over time in a very set series of steps. And forest fires are a great example of secondary succession where an area is destroyed by a fire. So these things do happen naturally, but slash and burn is a human anthropocentric or anthropogenic method that we're contributing to greenhouse gases in our atmosphere. So now we are moving on to sustainable forestry. This is 5.2. All right. So ecological sustainable forestry is going to be all about the different forestry methods that we use to get lumber. So lumber is wood, okay? And these are going to be methods that minimize damage to ecosystems, habitats, soil erosion, so on and so forth. So here we go. All right. So here are a few different ways. Selective cutting or strip cutting. Selective cutting is purposefully picking certain trees to cut down, whereas strip cutting is cutting like a whole strip of trees. So I like to use this example in this scenario. Selective cutting is like kind of like plucking your eyebrows. So you're like plucking specific hairs you want to remove. So you're cutting down specific trees you want to remove. Whereas strip cutting is like getting like a whole area of your eyebrow waxed off, or like getting a part of your leg waxed. Now, if you don't really understand what I'm talking about, um, the trees are again still a fine example. Selective cutting is only cutting a select amount, ones that you pick, um, and strip cutting is cutting a whole row. So we can use animal and pack animal labor to minimize soil compaction from machinery to prevent soil compaction so we don't have so much runoff and mudslides. Um, this is better overall for the soil. And replanting the same species being logged, so making sure that whatever we're cutting down, we're growing again. And this is going to maximize long-term productivity of land and preserve forests for future generations. Using recycled wood or simply reusing without recycling, so like Facebook Marketplace, thrifting, refurbished wood, that is all way better than buying new and buying, promoting the lumber industry. Wood can be chipped and used as mulch for gardens or agricultural fields. Reforestation is the replanting of trees in areas that have been deforested, and we can see that here in this image. Selectively removing diseased trees to prevent spread and infection through the entire forest. Removal of hosts for disease, decreased density, If an area is more dense, you're going to have a higher chance of disease spreading. All right, now let's talk about fire suppression. This is something that we do in New Jersey. So forest fires are very common. They are good for renewing ecosystems. That is in something that we'll talk about when we discuss ecological succession and secondary succession. But we do want to make sure that they don't get out of hand, out of control, and they are becoming more common than ever before because of global climate change. So the first thing is stopping natural fires. Fire suppression is the practice of putting out all natural forest fires as soon as they start. This leads to more biomass buildup. Putting out fires immediately leads to more dry biomass buildup. Remember, biomass is just the weight of life or dead organisms. It makes future fires worse, and we want to make sure that we're monitoring instead. Close monitoring can prevent fire damage and worse forest fires in the future. Prescribed burns are when we are specifically burning an area. And what is this doing? It's going to be using burning the dead biomass buildup because this dead biomass buildup is the fuel for large forest fires. The stored nutrients are trapped in the dead biomass, and dead trees are more susceptible to disease and pest spread. Small controlled fire burns a lot of dead biomass, so it uses up that dead biomass fuel, preventing the larger forest fires later. And this promotes nutrient recycling. That way, nutrients can be recycled through ecosystems. And that is all that we're going to talk about today. If you have any questions, let me know. Please make sure that you filled in page 2 and 3 of the notes. And I will see you guys